Hello, my name is Steve Barton. I'm here for Solid Rock Machine Shop Incorporated. Today we're going to do a little bit of hard turning on the mill. There's many times when you may come across a project where you might need a step pin for some reason or other. I know at my full-time job sometimes there's an engineering mistake and they'll have, say, a 1/2-inch dowel pin on the base of the unit, and they'll have a 3/8 in the part that has to be made on top of that. Well, instead of trying to scrap the part out or take and open up the 3/8 hole, a lot of times what they'll do is they'll just make a 2-step dowel pin, and they'll go to a lathe and hard turn a dowel down. Well, you can do the same thing in a milling machine, and we'll do that today. What you need a lathe tool. You can hold these ceramic inserts in this lathe tool. These are Acer inserts. They're some of the best ceramic inserts that I've ever used. We've tried out many, and these seem to hold up the best. We'll hold this lathe tool in the vise here. And before I have done this, I measured it because we need to get on the exact center line. And I measured from the bottom of the tool to the very top of my insert. I measured that out, and it was 1 inch and 2/1000ths. And so you'll need to know that number. And what we'll have to do, I just want to show you, I drew an insert over here. If we want to get the exact center, I got to subtract a few thousandths. These inserts come with what's called a T-land, and that T-land is this little angle that's right in this area right here. The top of the insert's right here. It's usually, I think it's about 20 thousandths wide. It's about 2 thousandths low. And so what happens is the top of the insert right here on that tool measures 1 inch and 2/1000ths, but the actual cutting tip is 2 thousandths lower than that. So that works out good, because now when the edge fine off the back, I can move over and go exactly 1 inch. So we'll put our edge finder in. Michael, you want to turn on that 3-phase generator? We leave that off because it generates a little bit of noise, so you have to put up with that for just a second. Right there, we just hit the back of the part with the edge finder. The tip that I used is a 200 thousandths. We need to wind half of that, and then we got to go exactly 1 inch. And so I'll just, instead of going 100 thousandths over, resetting the digital to 0, I'm just going to go over 1 inch and half of that diameter there, which would be 1 inch 100. I like to come past and come back this way for the pressure in the machine, the way the tool's set up, so that my cutting pressures are set better. You want to snug the table down and go ahead and reset 0. Take the edge finder out. Dowel pin in. Again, this should be cutting at almost about 3,000 RPMs. going to do is I'm going to make a 1/2 inch step, so I'll put a 1/2 inch gauge block in here. I'm just touching on the bottom. Pull the bell pin out, and you can see I'll end up with a 1/2 inch step. What I'll do at this point is I'll just come over and lightly touch on the side. Compressor just kicked in. And I'm just going to take just a light cleanup cut, take your micrometer. We're measuring 495 9/10. I'll set 0 here. What did I say, 495? Yeah. We'll just say call it 496. You can divide that by 2, which is 248. You're going to wind over 248. Reset 0. Now that the cutting edge that I've done the diameter on is set at 0 on the machine, or on the spindle here. It's sitting on the same 0 line. I've done that because now I'll know exactly where I'm at on the diameter. With this Accu-Rite, I can turn around and I can change this from a radius to a diameter on the settings, and by doing that I will get a 1. If I wind in 1/1000, or let's say if I wind in 10/1000 right now, I'm taking 20 off that pin. If I wanted that to read more accurate, I can change the setting, and so that if I wind in 10 here and I got 20 off the pin, it would actually show 20 on the scale. I don't like doing that because if I forget to change it back and I go into my mill work, and then I'm going to be off. In the mill work, if you're coming and you're side milling something and then moving over 10,000, you get 10,000s. When I cut 10,000s off this side, I'm also cutting 10 off that side, so I got to double everything. We want a 3/8 diameter, so I should be, at my finished size, I should be sitting at 187 and a half if everything's perfect. I'll wind back, we were at 248, and we'll take about 10,000 off on a cut. You want to snug down your wheel just a little bit so you don't get jerky movement in there. The ceramic, it's basically glass. It can't take those kind of jerky movements without breaking and chipping. You're basically cutting with glass. Okay, let's get some back. 30, that's what we need that. I should be within about 10 thousandths right now, and so we'll take a measurement. Like 385 and 1/10. At this point, when I want accuracy, I like to sneak up on it a little bit and take lighter cuts, and then measure between each cut. Other thing I like to do when I get a little closer, I like to snug the table down just a little bit so I don't get any vibrations moving me further than I want. I'm 379 and 3/10. Now we're 375 and about 8/10. Should do it. 374 and 8.5, about 9/10. We're about 1/10 off. One thing that you would probably want to do, the ceramic does cut with a little heat before you take your final couple cuts. I mean, it's not excessive, but before you take your final cuts, you might want to take and blow it off with an air hose, kind of cool it back down so you don't have thermal expansion if you're doing something real fussy. Another thing that I'll do sometimes if I want this to be really fussy, we'll just make it so that it's about 2/10 high, and then I'll take some real fine sandpaper and then I'll bring it in with that. If it's something that's longer and you got a little bit of taper in it, that sandpaper works good for getting the size right in on that last few tenths. The dowel pin, dowel pin is a hard material. They'll rock well, they'll average around 60 rock well. So you need to use ceramic or borzon to cut. Carbide will cut it too, but the ceramic, it works really nice. Borzon works real nice. Ceramic's very brittle. If you have interrupted cuts, you're not going to be able to cut with it. Well, you can if it's light interrupted cuts and a few tricks, but it's hard on the ceramic and you may go through a few tips. If you get the right grade borzon, you can actually go through some pretty nice interrupted cuts with the borzon and actually do some of this hard steel cutting as well. So you got your different choices. The ceramics are cheaper. You can get this insert for probably about 10 bucks. So you got you know, just a few dollars on each tip. There's 3 tips as you rotate it. The borzon that I like from Sumitomo, that has a single tip and it's about $20 a tip. But like I say, you can cut interrupted cuts with that. It can take a shock quite a bit better than what you can with ceramic. So that's just a nice little tip showing you how you can take hardened pins, use a ceramic cutter, you can cut steps. Now if you have a CNC knee mill, you can do the same thing in there, but then you can actually profile your parts, and you can actually whatever you program, angle, radius, blend them up, you can actually program that right in there. A knee mill, CNC knee mill, or regular CNC mill, you can do that, and you can end up what used to be a profile grinding, now you hard turn, and it's a lot faster. The accuracy is really good if your equipment's good, and it's save you a lot of time. Well, that's it for today.